So my name is Boris Parak. I'm from CESNET, and I will be talking to you about interoperability and OCCI for OpenNebula. So in the beginning, I will introduce CESNET and EGI Federated Cloud Activity. Then I will try to shortly explain what OCCI really is, what it does, how it looks like, and then I will go into rOCCI, our OCCI implementation, our clients, our servers for OpenNebula, and then I will try to provide some outlook for the near future and for the features we actually would like to develop and how we would like to continue this project. So what is CESNET? CESNET is actually an association of universities and the Academy of Sciences of the Czech Republic. So we are mainly based in the educational environment. CESNET is responsible for the National Research and Education Network. It's actually the network connecting different universities and scientific sites across Czech Republic. And we also operate the national grid infrastructure and are part of the EGI, which is actually an European grid infrastructure. European grid infrastructure has a project called Federated Cloud. You might have heard of it. It's actually an attempt to provide federated access to multiple cloud instances across Europe with different platforms, with standardized access methods, with standardized authentication, with standardized accounting, monitoring, and all these features that are necessary for a successful operation of a cloud infrastructure. And again, EGI is focusing on the requirements of the scientific community, so basically HPC computing in the cloud. What's OCCI? OCCI, Open Cloud Computing Interface, is actually an OGF standard, and it is a text-based protocol, an API focusing on interoperability, and was originally designed for infrastructure as a service clouds. This is important, but other important fact is also that this API and this concept of OCCI itself is very extendable and can be actually easily extended to support infrastructure as a service, platform as a service, service as a service, and other sometimes unrelated, directly unrelated things. For instance, some people like to say that you could actually operate a coffee machine using OCCI because some of the concepts are so generic you can actually implement anything you like. OCCI works with a few key elements. This is the actual diagram taken from the official specification, and as you can see, it's quite complicated. So I will focus on the most important points and elements inside this diagram. So as you can see, OCCI is working with kinds, actions, mixins, and resources and links. This means you actually have a kind that's basically a class. This class can be instantiated into an entity, or to be more specific, a resource. Then you can run actions. Those are actually those are operations you can actually run on a specific kind, on a specific resource. So to give you an example of an action would be the stop command on a virtual machine. You have launched a virtual machine and you would like to stop it, then you would like to resume it, you would like to save it. All these are examples of actions. And the compute element, the virtual machine, would be an example of a resource, which is actually an entity instantiated from a kind called compute. Mixins are designed to extend existing functionality and provide new functionality to existing kinds and entities and resources. So, for instance, you have a compute request that would actually launch a compute instance, virtual machine inside your cloud, and you would like to add contextualization. Contextualization can be defined as a mixin because it will define inside the already existing structure of a compute request a new attribute, and this attribute would actually be able to transport your public SSH key, your user data, anything you want. So this is actually a approach that will allow you to extend existing classes, existing kinds with new functionality, new attributes. This is a look on a specific part of the OCCI specification, because OCCI is separated into two main parts. The first part is OCCI core. That's the specification or the diagram you've seen just a few seconds ago. And this is a specific extension of this core principle to support infrastructure as a service cloud. So actually you can see here is the resource. That was the element that actually ended the previous diagram. And we have network, compute, and storage. Three basic elements in every infrastructure as a service cloud. And then we have links. Links are used to link different resources between themselves. So actually, for instance, you have a compute, and this compute element will use a disk or will use a network interface. And links are actually a mechanism that will facilitate this connection. So for instance, a compute instance has a disk, and this disk is actually a link between compute and storage. It's a storage link. It actually represents the connection between different elements in the OCCI schema. I know it's quite complicated when you see it for the first time, but if you are interested, I recommend reading the original specification. It's a PDF file. It's not that long. It actually it takes a few hours to actually get to know the principles involved and to actually understand the whole beauty of OCCI and how it works. So if you would like to know more, please go to the specification, and links are at the end of the presentation. And this is actually the resulting message. So if I want to create a compute element, a virtual machine, I will specify that I will actually need to do something with a kind called compute. I will use a mixin that specifies the operating system or the underlying image that should be used for this virtual machine, this compute instance. And then I will specify the resource template, which will actually define the amount of resources given to the virtual machine or the compute instance I want to launch. So this actually specifies a minimal subset of required attributes and information to create a virtual machine. As you can see, attributes at the bottom can specify additional information. You would be able to specify a number of cores, amount of memory. If you don't like to use predefined resource templates, you can actually define all this yourself, and then it's up to the backend to interpret this information and actually use the attributes you provided. Now to the rOCCI or rOCCI framework. It's actually a framework implementing OCCI in Ruby programming language. It also provides a shell-based user interface, and right now it's distributed as 3 separate components. It's rOCCI core, rOCCI API, and rOCCI CLI. And basically it's a tool providing interoperability between different cloud providers, between different cloud stacks or cloud frameworks. What is rOCCI server? rOCCI server is actually a server-side implementation. At the moment, it's targeted mostly on OpenNebula, and is actually a bridge between OpenNebula and the world of OCCI. Some of you may ask why, because OpenNebula already has an OCCI implementation. But as some of you may already know, this implementation available with OpenNebula is an implementation of a very early draft, and OCCI changed a lot from this draft. So it's actually completely different at the moment. The only similarities between the current state of the specification and the old draft are maybe the names for compute, storage, and network. The rest has completely changed. So that's why it's necessary to have a separate server implementation. Now I will talk to you about some of those elements distributed as a rOCCI framework. So a rOCCI core is basically a collection of classes. It doesn't do much, but it will allow you to implement your own functionality on top of OCCI. So it will help you handle and parse OCCI messages. It will help you generate OCCI messages. It will help you to convert messages into a class-based or basically class-based implementation of the rOCCI core. For instance, we've seen that there is something called OCCI infrastructure compute, and we have a class that will actually house all information about OCCI infrastructure compute. And you can call methods, you can set attributes on these classes, basically set of classes and helpers. OCCI rOCCI API, it provides another level of abstraction. It provides transport level functionality, so we actually implement client-side protocols, HTTP. We are at the moment working on AMQP, and it will actually provide a basis for a client implementation. For example, you don't want to handle authentication, you don't want to handle HTTP transport, you just want to write your own script or your own application. rOCCI API is the right thing to use because we provide high-level methods to just list available resources, to launch resources. So it's still a developer tool, but it can be used on a much higher level than the actual rOCCI core, which is just a bunch of classes. This provides functionality. For authentication, we provide some basic methods. We provide HTTP basic and digest. Then we provide certificate-based authentication with WOMS or X509. And then we provide native keystone authentication because we are actually able to communicate with OpenStack and OpenStack's implementation of OCCI to actually provide interoperability. So this is also natively implemented, and we can actually communicate with Keystone, get the token, and proceed to OCCI OS. And what's the CLI, the command line or shell interface? It's basically a gem for Ruby that you can install. Then you can install, and then you can run a basic subset of OCCI commands or OCCI actions on some resources. You can create, list, describe, networks, storages, virtual machines. Here is an example. As comments, I included some dependencies you actually have to install as native dependencies from your package manager before installing the gem. But the gem contains all the necessary Ruby-based classes. So feel free to try this. But you would actually need a endpoint at the other end, so it's not as easy to demonstrate. So what's rOCCI server? rOCCI server is a server-side implementation leveraging rOCCI framework, basically mostly rOCCI core, I just explained. And it supports basic authentication methods, basically the same as the rOCCI API. And it's a stateless proxy between OCCI world and OpenNebula. So the rOCCI server itself doesn't store any information. Everything is stored in OpenNebula. You can just launch multiple rOCCI servers on top of the same OpenNebula. It's simply a stateless pass-through proxy that will convert messages into native OpenNebula calls. Here is an example of the functionality. User will contact through HTTP rOCCI server. rOCCI server will parse the request, make a abstract representation that will be passed to the backend. The backend will call OpenNebula through XML RPC, and OpenNebula will respond. We will take the response, convert it into OCCI, and send it to the user. rOCCI or rOCCI server actually communicates with OpenNebula through the network, so you can install it as a separate appliance in a separate virtual machine. It doesn't have to be on the same front end or in the same user account as the original OpenNebula. So what's the representation? If you would like to know what is represented in rOCCI from OpenNebula, virtual machines are represented as compute, virtual networks as network, images as storage, virtual machine templates are represented as the OS template mixin. So if you create a native OpenNebula template, rOCCI server will allow you to access this template and to launch this template. That's the OS template mixin. And then there is a resource template mixin, which is actually defined inside rOCCI server because OpenNebula doesn't have the concept of flavors or resource templates. So you can actually predefine that in rOCCI server, and we will provide that for you. What are our plans for the future? We need to extend rOCCI core with latest developments in OCCI because some parts of OCCI are still in development. There are new standards that will be available, new renderings. There are some problems that need to be addressed. We will also add some more functionality to rOCCI CLI to actually support dynamic linking between storage and virtual machines, so we could actually add disk. Use the OpenNebula hot plug functionality to add disks, to add interfaces in runtime, and we actually need to implement action support, so you can stop instances. You just don't have to delete them. You can stop them. You can resume them. You can save them. That's actually not implemented yet because it's quite difficult across multiple platforms. Every platform has different definitions, and we are trying to stay interoperable. So actually, most of what I've just mentioned is doable across multiple platforms, not just with rOCCI server and OpenNebula, but it can be done on other platforms with compatible OCCI implementations. We are actually planning to rewrite rOCCI server. We have some design ideas. The most important part is actually we will support multiple backends. So if there are some platforms that do not support OCCI and don't have the manpower to develop their own OCCI, they will just develop their own backend and use rOCCI server to provide OCCI functionality to their platform. There are some details about the design, but anyone who is interested can talk to me or read that on the slide. And so what's the summary? Basically, OCCI is a generic boundary level interoperability protocol. What this means is that it's quite generic. This means it's difficult to implement, but it provides a lot of potential and functionality. rOCCI, or rOCCI, is an OCCI framework written in and for Ruby. So you actually need Ruby to develop anything with rOCCI framework. rOCCI also includes a shell-based interface, as you've seen, rOCCI CLI, which will actually allow you to use the framework without any additional development. Just launch from the command line, and you will be able to perform actions. And then rOCCI server provides OCCI support for OpenNebula and soon for other platforms. Here you have some links with interesting ideas, information. The first one is the link to OCCI working group for all the specification documents, additional information about OCCI, about the development. And the other three, the first one is for EGI Federated Cloud, and the two pointing to GitHub are actually our repositories. You can check out the code, open issues, submit pull requests. It's all up to you. So thank you for attention. If you have any questions. Okay, so the question was whether we have, other developers would have to rewrite their clients. It very much depends on how well or how compatible their implementation is with the current version of the standard. Because it's quite difficult, as I have tried to demonstrate in the beginning. OCCI is very generic, and there is actually a room for interpretation. So it's quite difficult to say, okay, this will be compatible, okay, this won't be compatible. But part of the work we are actually doing is to talk to other developers and to try to find the common ground, to actually make most clients work, most servers work. So if anyone has a specific problem, don't hesitate to contact us, and we will work with any developer to actually either change our implementation to help him within, of course, the specification, or to help him change his implementation to support our implementations, or the implementation of OCCI we see as the right one, or the one closest to the specification.
Any more questions?
We've tried with of course, rOCCI server because it uses the same core. We tried with OCCI OS, which is the implementation for OpenStack. This works also, but you have to use the latest version, probably from master from thesis repository on GitHub, because some of those changes are quite recent, maybe 2 weeks old. But we can actually at least describe launch virtual machines, so the basic functionality is already there. And we can also communicate with Cinefo. That's a Greek platform which is actually quite based on some APIs from OpenStack. So they share a lot of code. So they actually took OCCI OS and modified it a little bit. So it's basically the same implementation. But those 3 platforms actually work at the moment. We have some work already in progress with WNode. That's an Italian implementation of a cloud management framework. And that's probably about it. I'm not aware of any other implementations.
Do you know many people that use the Python client or the ONC server?
A Python client? There is a Python library that actually implements OCCI, but I'm not sure who is actually using it and whether actually someone tested it against the rOCCI server. Because a lot of people are claiming they actually have clients, but they basically have libraries. So you actually have to implement something on top of that library. And it's difficult to test it, because actually Python is not I'm not very friendly with Python. So I can't test it myself, but if someone is up to the task, and I will be happy to help you or assist you in any way to actually test with other implementations.
Tried some Python stuff 2 days ago or something, the OCCI client, not OpenNebula. And basically, the main issue with Python is that there is no DTD declaration in the XML if you return XML. It will just not parse it. So as long as XML-ish output is really valid, it's okay with Python.
Okay. Okay, that's the problem, because as far as the standard is concerned, there is no standardized XML rendering for OCCI. So you can actually render OCCI in 3 supported ways, or the 3rd way is not yet standardized, but it's close. It's text plain, which is actually text messages inside the HTTP body. Then it's text OCCI, which is actually the same content, just in HTTP headers. And right now, the specification should be arriving shortly for application OCCI plus JSON, basically a JSON rendering of OCCI, which is probably the nicest, because you actually don't need a OCCI specific parser. You can parse it with a generic JSON parser and then just access the structures produced by that. But XML is not standardized, so it's actually quite hard to implement the right way to render OCCI into XML.
Any more questions? All right. Then, thank you, Boris.